Today's lesson is 6-7, solving radical equations. And a radical equation is just an equation that has a radical expression in it. So somewhere in there there's going to be a square root or a cube root. In order to solve one of these, here's your steps. You want to isolate the radical, that is, get the square root on one side of the equal sign all by itself. Square both sides, so that'll get rid of a square root. Or if it's not a square root, then you need to raise it to a power. We'll do one example like that. Then you need to solve for x. Just use PEMDAS to solve for x. And then you must check, because sometimes your solution doesn't work. Let's take a look at some examples. Here's the first one. The square root of x minus 2 minus 1 equals 5. My first step is to isolate the radical. So I want to add 1 to both sides. And that gives me the square root of x minus 2 equals 6. Now I will square both sides. Squaring cancels out the square root, so I have x minus 2 equals 36. Add 2 to both sides, so x equals 38. Now I have to check this. And remember, the way we check an equation is to take the solution and plug it back into the original problem for x. So is the square root of 38 minus 2 minus 1 equal to 5? We don't PEMDAS this, but we solve or simplify each side of the equal sign. So is the square root of 36 minus 1 equal to 5? Is 6 minus 1 equal to 5? Indeed it is. So that one works. So my solution is x equals 38. Next example is a little more complicated. Square root of x minus 12 equals 2 minus the square root of x. A little hard to isolate the radical since I actually have 2 of them, so I'm going to skip right to squaring both sides. So on the left, that's going to leave me with x minus 12. And then on the right, this needs to be FOILed. And if you need to write it out as 2 minus the square root of x times 2 minus the square root of x, do that. So when I FOIL, my first gives me 4. My outer gives me a negative 2 square root of x. My inner gives me a negative 2 square root of x. And my last gives me a plus x, because a negative square root of x times a negative square root of x is just x. And this will simplify to 4 minus 4 square root of x plus x, because negative 2 square root of x plus another negative 2 square root of x is a negative 4 square root of x. So I'll put that over here. Okay, now I need to isolate my radical, and this is a little bit easier. I'll subtract 4 on both sides, and I'll subtract x on both sides. So I'm left with a negative 16 equals negative 4 square root of x. Divide both sides by divide both sides by a negative 4. 4 is equal to the square root of x. And when I square both sides, I get that x equals 16. So let's check that. Is the square root of 16 minus 16 minus 12 equal to 2 minus the square root of 16? Remember, it goes into the original equation. So is the square root of 4 equal to 2 minus 4? Square root of 16 is 4. Is 2 equal to negative 2? It is not. And that was my only solution, and it doesn't work, so my answer is no solution. That's why you have to check. Sometimes squaring both sides of an equation can give you extraneous answers. It may appear that they work, but actually when you plug them back in, they don't. Here's our second example. Again, I have a radical on both sides, a square root on both sides, but I don't have anything added or subtracted to it, so it's a little bit simpler. When I go ahead and square it, my square root signs just go away. And now it's a very simple equation to solve. Subtract x on both sides, add 2 on both sides, and divide by 6. The only problem is my answer is a fraction, and this is going to be a pain to check, but we still need to check it. So is the square root of 7 times 5/6 minus 2 equal to the square root of x plus 3? No, I'm sorry, not x plus 3. 5/6 plus 3. And I think the best way to do this is just use your calculator, plug it in. You're going to get a crazy decimal on this side. You're going to get a crazy decimal on this side, and they do end up actually equaling each other. But do this in the calculator to check it. And our last example actually doesn't have a radical sign in it. Instead, it has an expression raised to the 1/3 power, which, if you'll remember from the lesson we did on Friday, something to the 1/3 power is actually a cube root. I'm not going to rewrite it as a cube root. I'm going to treat it as the 1/3 power. So I want to get that all by itself. So I will subtract 4 on both sides. Oops, a little sloppy. Divide both sides by 2. Oops. To the 1/3. And I divided by 2, so that's a -2. Now, to get rid of that 1/3 power, I'm going to cube it. I'm going to raise each side to the power of 3. Okay? Because remember what that does when you have an exponent inside the parentheses and an exponent outside. Actually, these are square brackets, but the same rule applies. Exponent inside, exponent outside, multiply them. That's going to give me an exponent of 1. So I'm left with x minus 10 equals, and -2 cubed is -8. Adding 10 to both sides, x equals 2. And let's go ahead and plug that back in for our check. So 2 times 2 minus 10 to the 1/3 power plus 4, is that equal to 0? Is 2 times -8 to the 1/3 power plus 4 equal to 0? Okay, so you need to don't do 2 times -8 first. That would be multiplication. PEMDAS says we have to do exponents first. So I need -8 to the 1/3 power. That's the same thing as saying the cube root of -8. If that doesn't jump into your head right away, use your calculator. It's actually -2. Plus 4, is that equal to 0? -4 plus 4 does indeed equal 0. And that one works, so my answer is 2.